All right, I think my audio is good. Um, I'm going to do a quick stream today. I don't really have much time, so I'm going to try to knock this out in an hour. I may not complete the challenge, but um, hopefully we'll learn something along the way. So when we last left off, we finished the reentrancy attack. So we learned a few things there. We learned, actually, let me open that up just to do a recap. Um, So this was actually the first time that I learned how to use type chain with TypeScript. I was primarily using JavaScript. Um, and so with this challenge, I pretty much learned how to uh, implement type chain and kind of just use that when running tests. Um, and so yeah, we pretty much had our reentrancy um, contract here, or our reentrance contract, and then learn how to create an attack to exploit that reentrancy. So all went well, completed that challenge, and now we just have to move on to elevator. So let me drop this. All right, so I think this is all updated. Yeah. So what I'm gonna do is was it? Is it elevator? Yeah. Git branch elevator. Okay. Let's do some housekeeping things. We're pretty much gonna clear out this attack right here. Clear this out. We can import. Let's just pause this for a second. Same with this. I don't think I'm gonna need any. Yeah, I really honestly don't think I'm gonna need any of this stuff, but we'll see. Um, Also, we can get rid of this reentrance. So we're supposed to be using elevator. Let's change all this. And let's rename this to elevator.soul. Okay. So we have our attack template. Contract attack local and with Zapolia. So I think I want to petition to add this to, not petition, but I think I want to change this right here. Okay. Just leave that as an attack template right there. And what we're going to do is do a few things. So let's first figure out how this thing needs to work. So the elevator won't let you reach the top of the building. Things that might help. Sometimes Slade's not good at keeping promises. This elevator expects to be used from a building. Okay. So I need to figure out if this is going to be a contract attack or a um, just a externally owned account attack. Um, so if we review this, so interface, so this will be calling contract. Okay. Um, Essentially, what an interface lets you do is call some other contract code somewhere else. That's interesting. Is last four. Okay. Elevator top with you on public floor, which is false. Or top is going to be false. So if we tested this and tried to view the floor and go to it, I think the floor is always going to return. We'll never get to the top floor. Um, because if we call go to with our externally owned account and it tried to get some code of, it tried to call or turn this into a building contract, this is gonna building that is last floor. Let's say we passed in a four. Four is hmm. So don't know what this. So it's called an interface. Yeah. So building. Four. It's like no matter what you would call, this is gonna return false. Let's just see. Let's try to tamper with it. We're gonna do this all locally first. So contract detect local, and let's actually just say we'll just leave it as contract because we know that's probably what we're gonna get to. So um, let's say elevator exploit using contract. So we have attacker contract. We're gonna have a elevator contract. We're gonna have an attacker contract address, and we don't really care about a final balance right now. So we can just leave that there. Um, hmm. Then what we can do, actually, I don't even think we care about an attacker right now either. But let's go ahead and just deploy these. So that should be lowercase. Let's get an elevator contract going. And it's going to be at elevator. I think that should have been, yeah. That should be elevator contract factory. Just change that. Okay. That's going to be an elevator contract. Why is that giving me issues? Oh, okay. So first off, yeah, that's why I like type chain. We need to do yarn hardhat clean. Actually, I may need to change node to. Let's compile these. Nope. Oh. Okay. Let's try that now. Nope. What is 0.6? Okay, let's try this now. Okay, so we've generated all the types. Um, Interesting why this console log is not found here, but it's okay for now. We're not planning on using that. At least right now I don't. Yeah, that's kind of weird. So we have our elevator, we have our attack contract. So now our ooh, no, I don't need that. I need this. So elevator contract is not going to be of type reentrance. It's going to be of type elevator. Okay. And then we want to make sure this contract was deployed. I guess we can deploy our attacker contract for now. There's really nothing in here we need to do especially. Tag, that stays the same. Okay. So we're going to, in this one, we're going to test the elevator calls or test elevator state. Okay, let's get some of this out of the way. So I guess it'd be best to take honestly all this crap out. Because there's just a few things that we want to do specifically to this elevator contract. We don't need final balance right now, and we don't need this perform exploit right now. We just want to test some stuff. So what we're going to do is maybe we can just split this. So first, I want to see what this. I want to see what goto gives us. Like what happens when we call goto. So uh, let transaction goto await elevator contract dot goto. Let's go to floor 4. And then let transit receipt wait um equals await uh transaction go to dot wait, and then what we're gonna do is get like go to wait get top equals wait what we're gonna get, let's just get the top for now. See what it says, and then let's see what floor is. Let get floor equals await elevator contract dot get floor. Okay, and we're going to okay. Top. All right. Let's just see what happens when we run this locally. Because I want to see how we interact with this contract. So we're going to say yarn test. Okay. So yeah, theory is right. It's trying to call our contract, and it's thinking the message.sender is a contract, and it's not. Flushing fall to a non-contract at elevator. Soul line 16. Yes. Yep. So basically, my externally owned account, this building right here, is not an actual building. So, I think what I need to do is create an interface or create a building contract. So let's look up how do we call, how do we, just say, how do we use an interface? Solidity by example. Okay. Interface modifiers. Nope. 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 Interface examples. Let's look at this one. Okay, so we have a counter, we have an interface. It looks like this interface is calling counter count increment. Okay. Yeah. So it looks like what I'm gonna do is I'm gonna, instead of calling this attack, let's call it building, right? Because I'm gonna make my own building contract and it's gonna think I am calling that exactly. So we're gonna make sure we create this, and what this function is gonna do, turns, yep. Yeah. So what we're gonna do is in ours, it's always gonna return true. Let me see something. Why is the console log not working? Turning true. I don't know why we're getting this error. I wasn't getting this last time. Because the other day this was working perfectly fine. Did that not work? No. There we go. That should work. Okay. So when we call this elevator, actually, let's compile, because it looks like this thing is tripping for this. Okay, this compiles. Um, so that when we call is_4 of my contract, we are going to get a true. And so we're going to, we also need to pass a function initiate attack. And what we're going to do, so we actually do have to do something. We have to import elevator. Hey. I don't know why we got that. Do constructor. And we're going to say address. I'm going to say elevator contract. Okay. And our constructor, we're going to say contract. When we initialize this thing, it's going to be the contract is equal to elevator. Also, should be an address. And we're going to pass in this elevator contract. Okay. Still having a ton of issues. Is it because of this? And this? So we import our contract for elevator. Or I wonder if it's doing this because of the building that's identified here. Is that why? Okay, let's leave it at contract attack then. And I think this interface building, so shouldn't we have a contract building? Okay, so this should be called I building, and then my contract will be building, but it's okay because as long as we have yeah, what was this error we got a while back ago? Non-contract account. Okay, yeah, so this just needed to be a contract account, which we do. We have an elevator contract that we're gonna plug in. So when we call this, it's gonna first, it has the elevator contract address. Then we're gonna initiate this attack, and how we're gonna initiate it is we're gonna call elevator contract dot go to, and we want to go to any floor. This should be unit. Let's say unit floor equal to 5. Okay. Oops. Let's say top. Then we're going to say go to top. And so how I'm thinking of this tag is going to work, it's going to call go to top, right? And the message.sender is going to be the contract that we're sending it from. So it's going to think it's a building. And what it's going to do is, since we have interface for is last floor, it's going to call building is last floor, and it's going to say 5, right? And is last floor is going to return true. Wait. Building is last floor. Building is last floor. I'm just going to say okay, so we're going to do something trickery here. First, we're going to have to make this false. Yeah. So first, we have to make this false. And then once this is called, once that's going to equal to, this is first going to equal to false. Oh, return toggle. So let's see. I think we have to use some concept of like a mutex. Um, I'm struggling to think about the solution right now. So let's say this executes is last floor and call go to floor 5, which doesn't matter. Then it's gonna call is last floor, which is going to return false. Then we can say true maybe. So let's say it calls this go to bam message sender bam if is last floor. Yeah, no, it's not gonna come out of here yet. Is last floor is equal to 5, whatever we pass in. It's and return true because we're going to say false. Let's see. Let's say you went okay. We have to do a different path. So instead of toggling it, it's going to be if top equals 5, then what we're going to do is we're going to return um, false. Else turn true. That's going to be the toggle. Okay. So first we're going to pass in 5. Or am I tripping? Elevator. So first it's going to pass in 5. 5 so I'm going to this. Actually don't matter what floor this is. We're going to get to the top. So we're going to call this count. Okay, I think I see. Count is equal to 1. So if count equals 1, actually let's say count equals 0. We're going to say count plus plus. Then it's going to turn false, else it's going to turn true. So we're going to make the top floor 5, and then we're going to, we don't need this toggle down here. Yep, and we don't need toggle. Because this essentially is going to be like a toggle. That's one way we can do it, and also we can keep toggle. I think we can also just say Boolean toggle and say if not toggle, return false. And then also, we even honestly don't even need a whatchamacallit. We can just say return true. I think this one's a little bit cleaner. That may be a cleaner solution. I think that's essentially what we're doing is toggle's gonna be false. So this is definitely gonna be false. So if true, return false, which is what we're gonna need. And then we're gonna say toggle is equal to true. Okay. And then in this next iteration, toggles will be equal to true, and this is gonna return this right here. It's kind of like a mutex. I think this is what this concept is kind of teaching, as well as with interfaces. So we don't need count because I feel like that makes it a little bit tricky. We're gonna call this go to. Just gonna call initiate attack, and it should handle everything for us. So I think that's how this attack is supposed to work. I could be completely wrong. No, I don't have type chain. Okay. Okay, I was gonna say that's iffy. I don't have type chain. So let's clean all this. Then go here. Okay. I don't know why it's saying we don't have our type chain types, and we absolutely should. Yeah, we do. What's the issue? Okay, good. So that just means we need to do this constructor. Okay. So when we deploy our elevator contract, or sorry, when we deploy our attack contract factory, we need to deploy it with the elevator contract address. So that's how we're going to know what we're calling. Then once we deploy, we're going to call, so that's test elevator state. We don't need that. We want to do perform exploit. And in this exploit, let's also scratch this out. In this exploit, we're going to do a few things. Call attack contracts go to, or attack contracts initiate attack. Okay. So after that, we're going to view the state of top and verify that it's true. Okay, so let's call let transaction attack equals attacker contract dot initiate attack. Okay, let transaction let the attack equals 2 dot wait, and we need to make sure we remember that it's async function, so it's going to be a wait. And then what we're going to do after this is let get top. Equals await elevator contract dot top. Okay. If I could have just did that quickly. That's how I think this attack is supposed to work. So I'm gonna run this attack. All right, top has been set to true. We have successfully hit the top. I think that is the challenge. Now this is all done locally, but in the next session, I'll probably sometimes like the top building, right? Yeah. So the idea is we're going to learn how to do this and set it up live. This was just a test run locally so that it can be done. I'm about to hop off, but just to quickly explain this attack. So was tripped up a little bit, but the idea is we have an elevator. It makes a external call. It makes an interface call. So essentially, it's assuming that this message sender is going to be a contract. And once it does that, it wants to call that contract that we just set in the interface. It wants to call that contract, check what the last floor is. The first thing needs to give you a value of, it needs to give you a falsy value because that's how we're, I mean, this is the not equal operator. So not false would be true, which would allow us to enter into this conditional. And once we return false, this is last floor needs to change and then return true. And at first it stumped me because I was like, how do we make it another value all in one transaction? But I realized we had to just make some type of toggle or mutex type of thing where it runs and it will return a value, and then when you go back into it, it's going to return another value. So essentially, in the floor does not matter. This is like, it really doesn't matter what you pass it in for the floor. We could have made it 0 for purposes. The idea is when we go to our attack function. Oh, another thing I thought that my contract had to be called building, and that is not the case. I guess the interface cannot be called the same thing as that contract it's calling. So that's why people usually you see I building, and that makes so much sense to me now. So essentially in this attack, we have to make sure we pull in elevator because we want to eventually call this contract from our attack contract to make this message.sender statement make this successful. So we pull in the elevator contract, pull in the address, all right, and then we make the call go to, because remember we want to make a call from this contract, and then we want the interface to use something we've created, right? So we have function is last floor, UN external returns bool. This has to be the exact same thing as this interface here, or it's not going to work. Honestly, I don't know if this being a view function, if it would have changed it, but it needs to be the exact same thing in order to actually be a correct interface. So it's going to call in. We're going to pass in some random value. We use 5 in this case. And toggle. Also, another thing is the initial value is false. So if someone sets something like bool, whatever, that value is going to be false. So not false is going to be true, right? And then we're going to enter in, we're going to change toggle to true, but we're going to return false. Okay, so that's going to return false here, and then not false is going to be true. We're going to enter in, floor is going to be set to 5, and then it's going to do one more call again. Building is last floor. Floor, remember it's calling this is last floor here, which is connected to here. And in this next call, since toggle is true, not true is false. So it's going to skip this statement and then it's going to return true, which will successfully complete the challenge. So I'm pretty sure this is correct. All we have to do is just like a few things. We would have to expect get top. Let's say get top is equal to is of type Boolean. And it's going to be this right here. And we're going to say get top equals await top. And then for this final one, we're going to expect get top 2 dot b equal to true. Okay. We can scrap this because this was a test. Let's take all of this here. Do the real one. We want to perform the exploit, so we're going to do this here. We're going to actually ran out of time, so what we're going to do is we'll come back and well, hold on first. Let me check. Baby. All right. I will I'll finish this one out and then call it a night. So for the Sepolia, we want to do a few things. Also, this won't be shouldn't be a part 2, but let's go ahead and do this for a second. Get our transaction. Should be on Sepolia. Should be on my test. Okay. All right, so we have an instance address and a few things here. We have to let elevator contract. We don't have to deploy it this time. Await. First, let's say contract address is going to be equal to this right here. Let's say get contract factory. Actually, I don't think I need that one. I think I need get contract at. Yeah. And I need to get it at this address. We're not deploying it, so we don't need elevator contract factory. We have the elevator contract here. I'm pretty sure that's how it goes. Yeah, that's the right way. So we have our elevator contract. Yeah, we'll type elevator. Type elevator. We have our attack contract. And we're definitely going to pass this in. Get the address. deploy that. Okay. And then we're going to perform this attack. Yep, yep, yep. Okay, so this should be the case, and now all we gotta do is deploy it. So this is here, it's already deployed. Now mine's deployed. All right, so now all we gotta do is this, change the network to Sepolia. I believe so. May have messed up something, but we'll see. And if this messes up, then we're gonna call it a night and we'll figure out the debugging piece. It may be something that I did wrong in terms of like on chain or not. Okay. Top has been set to true. Looks like we passed that. So now let's go to Ethernaut and submit this. And we should have successfully gotten to the top. At least I think that's what the challenge is. If not, then we'll have to tinker with it and figure out in the next challenge. Not in the next challenge, but in the next session. Oops. All right, so I did not do it. Did I do this on the right one? Ah. You know why? It's because we did it on, we just literally deployed. All right, now let's try this. Local basically was not, it wasn't doing it. It was just deploying everything to testnet and running the attack. It wasn't actually grabbing the contract that we were grabbing here, right here. Nope. So it didn't even step into this. And that's because we did that wrong. So contract address, elevator contract, see, get top, Boolean value. Okay. I wonder if, that was the issue. Or at least I think it was. It's just simple things that you really gotta pay attention to. And I did it again. This is messed up. Same with this attacker contract factory thing. So there is no such thing as an attacker contract. Oh wait, it is. Okay, that actually should have worked. We'll see. Tag contract, tag contract. Yep, yep. Let's see if we can see this on chain. Mm-mm-mm. Mm-mm-mm. I think this just happened. No, this is pending. All right, now it's set to be true. This should have went through. We go check the transaction hash. We call from this to, I'm assuming this is my contract. Transactions, yep. This one needs to be like an internal state one. Hmm. Now let's submit it again. Boom. And this should be it. Because we deployed it live to the actual one, we ran it on Sepolia, and yep, we are good to go. So that is pretty much the challenge. We are, I did not mean to do that. We completed that level, so in our next stream, during my next study session, I'm gonna attempt privacy. This looks pretty yucky. It's very yucky, actually. So this probably will take a lot of time in our next session, but we finished this one. So if you have any questions, feel free to DM me. And yeah, enjoy the weekend, y'all.